Thanks everyone for joining. I'm Nick Hallstrom with EMR Associates, and on the line we've got Bridget Davidson. She is a business development manager with MELTRIC. She's going to do a presentation here going over some NFPA code considerations, and then also how our MELTRIC switch-rated product line helps simplify compliance with those standards. So I'm just going to let Bridget take it away. If you guys have any questions during this, feel free to either chime in, or there is a chat, and if you want to post your question to the chat, I can answer that while Bridget's doing the presentation, or it's one we could address afterwards. So she'll go over this presentation and then ask some questions, and then we do have some applications we'll cover after that. So I will let Bridget take it away.
Hello, everyone. I'm Bridget Davidson with MELTRIC Corporation, and I'm going to be presenting on NFPA 70E code and how we fit into that, simplifying the code. So it's not changing. There it goes. Okay, so with code compliance, we've obviously got the NFPA 70E, the NEC code, and now we're coming up with the NFPA 70B that all sort of fit in together. And no one code is actually the law. The law is that you keep your employees safe, and it doesn't really go into how, but if there's an accident and something happens, they will refer to these codes as industry standards and decide whether you have actually followed the basic standard. So you can go above and beyond these codes, but if you haven't followed these, there has to be a really good reason, a really good justification for why you didn't when something happens. And obviously, if there's problems with your compliance and with these issues, OSHA is going to have a problem with it and maybe fine you. So I'm just showing this slide. I went to the ESW a few weeks ago that the IEEE puts on, and it just went over some of the recorded fatalities and the different things that caused fatalities in the workplace from 2011 to 2018. And this is why we have these standards, so that everybody can prevent these fatalities from occurring and reduce injuries in the workplace. So you may see in this slide that they're going up slightly, and there was an analysis actually in this presentation that since 2015, 2016, we've had an insurgence of workers that cannot speak English. So that's why they think these injuries are going up right now. So they're encouraging people to have other ways of communicating with their employees to make sure everybody understands. And there's also an increase in worker fatalities that are not electrical workers, people that get into power lines and things like that. So anyway, that's a side note of why they've gone up a little bit. If you don't have good zero energy verification procedures in your workplace, the result is obviously fatalities and injuries. So the kinds of hazards that we're talking about with zero energy verification are shock, disconnecting electrical connections. You can have an arc flash. This can also cause burns, but also aside from the electrical hazards, the equipment that people are verifying zero energy on could start while somebody is doing electrical, or not electrical maintenance, but any kind of maintenance on that equipment. And they could get fingers, arms, legs cut, severed, things of that nature. So I've actually met a few people that have had that happen to them. When we're looking at the code, so obviously Article 120 in establishing an electrically safe work condition is important, but I'm not saying that Article 110 or 130 or 140, those aren't important. They're just, I'm just going to show how MELTRIC can actually help in establishing an electrically safe work condition, and some of my justification will be in Article 130. And in Article 110, obviously, hopefully you've already got a risk assessment procedure and your people are trained for the work that they're going to do. With Article 120, obviously it says that you've got to have a lockout tagout program. You've got to have principles in this program. You've got to have the equipment to do it, and you have to have procedures that are in place for the people to follow. And it outlines that the most effective way to prevent electrical injury is to completely remove the sources of electrical energy and eliminate the possibility for it to reappear. So you've got to identify all the possible sources of electricity and employ a safe lockout tagout procedure on that. So I actually have a few slides that go through exactly what the code says. So I have a code book here. If anybody has any questions, I'll look at the book as well. But it specifically states that you have to open the disconnecting devices for each source and visually verify that all the blades have become fully open. So those are really important. So once you do that, the code says you have to do this, but when you do, with a lot of equipment that's out there, you become exposed to bare live conductors. So the bare live conductors are one of the things that expose you to an electrical hazard. And then afterwards, you've got to apply your lockout tagout devices, and you have to test with a portable test instrument. So it says you've got to test your test instrument before you actually use it. And then when you're using it, you've got to test each phase to phase conductor and phase to ground. So when you're testing, you're actually testing the bare live conductors, and that can be dangerous. And then just for the sake of being thorough, I put this slide that is actually new in the code, where it's discussing capacitance and impedance and how they have to be tested as well. But that doesn't really tie into MELTRIC too much, so I just put it there for you. So regular disconnect switches, the hazard that's occurring is that people are, like I said, being exposed to bare live conductors. So the reason why you have to test this, and some people don't understand why it needs to be tested. So with a bladed disconnect or a rotary disconnect or any kind of regular disconnect switch, one of the phases can become stuck. And you actually hear that everything's opened, but one of them stayed shut. So if you just trust in that, as some people have in the past, then there could still be energy there, and you could get shocked when you remove the plug or you disconnect the motor. So there's actually been recalls. I took the little hazard statement here. I actually cut that from recalls that have been posted for rotary disconnects in 2008. And in 2017, there was a very popular manufacturer of bladed disconnect switches that had to recall them for this specific reason, that one of the phases actually stayed shut and it wasn't opening fully. But other things I've heard in the field, guys tell me, hey, there's like bugs and lizards and small rodents that can get in the bladed disconnects. There's just corrosion that happens over time. And for that reason, over time, it's more and more likely that one of these phases could stick. So in order to test, because you're being exposed to bare live conductors, you've got to have a qualified personnel to do that test. So not just anybody can verify their own zero energy. You've got to get your electrically qualified worker involved. And this is the kind of PPE that he would typically be expected to wear when he's doing his zero energy verification process. Obviously, you'd need more PPE if you were being exposed to more incident energy, but this is a typical, at a 480 volt disconnect switch, typical PPE that you'd see somebody wear. And so you're gonna have your electrician and your mechanic in a motor change out situation, or your electrician and whoever's going to do any kind of maintenance required on equipment, that have to be involved every single time work needs to be done to verify that all of this energy is not present before work is carried out. So that takes a bit of a process. Electricians or electrically qualified workers are not always available right away. So that creates some extra downtime. It takes a lot of time with two people involved in the process anyway. So a lot of people are concerned with, oh my God, I've got all this expenditure on two workers, I've got procedures I've got to follow, and I've got so much PPE to consider, and it wastes a lot of my time in my facility. So obviously it can be costly. Article 130 kind of goes through when you don't need to have PPE. And one of the things that Article 130 states is that if you're under 50 volts, then you don't have to worry too much. But also, if you're being exposed to bare live conductors, that kind of thing. But it also outlines what a normal operation is, and you're allowed to perform work that is considered a normal operation without PPE. So if it's properly installed, maintained, and it's used in accordance with the instructions, obviously, and the equipment doors are closed and secured, and the covers are in place and secured. So you can't have an evidence of impending failure. So obviously, if you've got a wire with the insulation broken open and damage to some of the conductors in there, then you're in a more dangerous situation. So you're going to have to assess that before you get to all this zero energy. But if you were to operate a circuit breaker, a switch, a contactor, or a starter, and you weren't going to verify zero energy, if you were just going to throw the switch, then you don't need your PPE on, because your worker is not exposed to those bare live conductors and the opportunity for the arc flash and the shock to happen to them. So that's where MELTRIC comes in. So MELTRIC has a different kind of technology than a regular switch would have. It's much easier to verify zero energy with using a MELTRIC connector. And what we're looking to do is simplify your compliance and save on your operations and maintenance costs. If you look at this hierarchy of controls on the right-hand side on my NFPA 70E book, you'll see that when you're doing administrative controls and personal protective equipment, those are at the bottom. What they'd really like you to do is eliminate the hazards. So that's what MELTRIC does. It eliminates the hazards that a worker is exposed to. You're never exposed to bare live conductors, never exposed to the arc flash or the shock. So then you can get one guy to just unplug the equipment and plug in the new equipment. So obviously you're gonna have to have a little bit of a forward-thinking philosophy in how you treat a motor changeout. Your electricians are gonna have to pre-wire and pre-bump the motor, but then in the moment, whenever something goes down, the mechanic can do it himself. So it doesn't take as much downtime. It's much easier. There's no wiring and unwiring to worry about. It's just quick and easy. So you're gonna have safer, easier, and less costly operations and maintenance. Your systems are actually taking out the hazard of arc flash and shock with respect to zero energy verification. So this is how we work, how we eliminate the hazard. There's a dead front shutter on the front of it. So you actually, there is no limited approach boundary around the receptacle. There's no bare life conductor. So there's no risk of somebody getting shocked at that receptacle. Even if somebody hasn't put the cap on, it's still no risk of shock. And then when it's disconnected, there's an arc chamber inside. So the material that our conductors are made from is silver nickel, which reduces your chance of an arc occurring. It's designed to be disconnected under load, and it mechanically disconnects in 15 milliseconds. So that mechanical disconnection is going to reduce the chance of an arc occurring. And it's going to keep it nice and small. There's no, this obviously NFPA 70E feeds into NEC code and NFPA 70B. You don't have to service MELTRIC on the inside. You don't have to adjust it. You don't have to perform any maintenance on it while it's energized. There's no reason for you to perform maintenance on this. You don't have to worry about one of the phases sticking, because as soon as you disconnect the plug from the receptacle, you've got a big air gap, and you know all three phases and ground have been disconnected. That sort of fits into Article 110.26 in the NEC code that requires you to give a working space depth around your disconnect switches. So this can help you with not just NFPA 70E, but also designing systems that don't have to worry about that working space depth so much. And we don't have doors to open. So there's nothing to worry about with respect to arc flash or shock. So NEC code obviously says that you have to be readily accessible, switch rated, and horsepower rated in order to be a line of sight disconnect switch, and MELTRIC is all of the above. Lots of different ways you can mount it to motors. You can mount it straight on, you can have a cord-to-cord assembly, and you can use it with flex. A lot of people are like, oh, I have flex. Well, you don't have to worry about that. You can mount it in that way. So who says we're a switch? Is it just MELTRIC? No, MELTRIC had to go to UL and become rated as a switch. So UL has rated MELTRIC as a plug-in receptacle, an enclosed switch, and a manual motor controller. MELTRIC also has those standards with CSA, and if you need them, we also have European standards. These are all the tests that we did in order to get those ratings by UL. So we've done 50 operations at 1.5 times the rated current and voltage. We have an electrical endurance test with 6,000 operations at rated current and voltage. And this horsepower locked rotor overload with 6 times the full load amps. We've done that to get the horsepower rating. And we've done this extra short circuit closing and withstand to say, okay, would any energy leak out of the unit if there was a short circuit condition? And the answer is no. None of the arc was able to leak out of the arc chambers where it would be able to burn someone or obviously shock someone. So the first thing, which I already mentioned, is that we're made from silver nickel, and we fit together very differently than a regular plug-in receptacle. We operate very similarly to switchgear or a contactor, and we disconnect mechanically. So you've got a nice stable connection with optimal contact pressure. The mechanical disconnection happens very quickly. We resist welding and wear, and obviously the silver nickel is very corrosion resistant. So you'll see other plugs and receptacle rated units that are made with brass conductors, and that brass has a low melting point, and it will obviously melt. It's not meant for disconnection under load, and brass is very corrosive. So with MELTRIC, you're going to have a low temperature rise. It's going to last a lot longer in addition to all of these health and safety benefits that we provide. And you're going to have a nice, easy lockout tagout program now. So you can lock out at the receptacle or the plug. You can do motor monitoring with optional auxiliary contacts if you'd like them. They make, last, and break first, so you don't have to worry about VFD operations. Also, sometimes I have engineers that are reluctant to put in plug-in cord connected motors because of the risk that they would be introducing with a loose termination. Obviously, that's one of the main causes of fire in the US is loose termination connections. So with MELTRIC, we have an elliptical deforming ring, and that's going to prevent loosening. It's a nice spring-loaded elliptical deforming ring that keeps a constant pressure on your conductor, even if any kind of strand settlement or vibration or thermal cycling occurred, you'd keep a nice tight connection on your conductor. So obviously you're going to have to torque it to the correct torque, but that is also part of NEC requirements for installing electrical equipment. So you don't have to read all the instructions, but I would encourage people to read the instructions on the torque requirements for the termination connection. So you get that added health and safety there as well. You have type 3R or 4X, and we have IP69K ratings. So you can spray this down with high pressure steam and you're still good. Do you guys have any questions? I was going to talk about just some of the typical applications now, but that is basically how we would simplify NFPA 70E.
Bridget, MELTRIC's essentially a non-fuse switch and a standard plug and receptacle combination in one. Can you maybe talk about the difference of if someone already had a safety switch and like a twist lock, what they'd be gaining with MELTRIC, or what the process would be for your disconnect and plug application versus a MELTRIC?
So if you have anything over 50 volts, you're supposed to verify zero energy before you disconnect anything. So if you had a regular disconnect switch and a plug anywhere, you'd have to verify zero energy before you could unplug it. And that has been an issue. I've visited steel mills and other areas like food and beverage plants where they are very health and safety conscious. They follow NFPA 70E, but they just find that very time consuming for their electricians. They don't always have electricians available right away to go verify zero energy, so somebody can disconnect a big fan or some kind of pump or whatever. It's just not that easy to just unplug a piece of machinery. So with MELTRIC, anybody can disconnect it under load and it doesn't matter. So that's basically how we're different. We're a switch and a plug-in receptacle in one. So any other things? So I'm just going to go on to the applications that I typically, or just some examples. So obviously welding is a very popular application for MELTRIC. We're used in about 80% of the world shipyards, and it makes things a lot easier instead of needing electricians to verify zero energy before a welder moves his equipment. Now the welder can do it himself, which saves a lot of time. So I've actually done a little bit of an analysis for a shipyard when they were looking at changing all of their plugs and receptacles, which would, I mean, we were talking about a lot of money. They were going to say to get a return on their investment within 7 to 8 months because of how much they spent on welders waiting for electricians to verify zero energy. So they obviously like the idea of changing over. But welding receptacles are not just for welding equipment. I've got some examples here. Obviously, we talked about fans and coolers and steel mills. On the right, I've got a picture of welding receptacles in an SAP area and a plastic plant. And obviously SAP gets really slippery and when it gets wet, so they have to make sure they vacuum it up very quickly. So they've got a vacuum that travels all around the area to vacuum it up, and that's what they use those particular receptacles for, but any kind of portable equipment. So that's the next thing I have, portable equipment, and that's usually what a welding receptacle is for. On the left, we've got brewing equipment. On the right, we have low voltage pelletizers. And not only has it simplified the zero energy verification procedure and sped up their process for changing out a pelletizer, they also don't have to clean up a big mess that all the pellets went everywhere when they were verifying zero energy before. So now they're really happy with that particular solution. Any kind of pump motors, lots of water, wastewater applications that people use, but there's pumps in all kinds of areas, nuclear plants, everywhere I see pumps. Food and beverage conveyors to mining and aggregate conveyors. They obviously have a lot of motors that have slippage, so they're changed frequently. MELTRIC takes up a lot less room than a regular disconnect switch, so they can mount several in a smaller area.
I think that's a good point. That's something that makes retrofitting easy. You know, in a lot of facilities, they might not have a line of sight disconnect currently. So you want to add, you know, a line of sight disconnect to have a more convenient lockout point. MELTRIC being able to mount several different ways, including fixed on a junction box like Bridget's showing here, or even if it was just a cord-to-cord installation, gives you a lot of flexibility when you're doing retrofits as far as finding the fit that's going to be the easiest for the existing application.
Obviously, yes, thank you. Any kind of portable power distribution. So we've talked about the shipyards. So on the far right, you'll see a power distribution unit that they use, but sometimes people have different equipment that goes into generators. I think this is probably one of Nick's popular applications with one of his mining and aggregate customers, where they plug and unplug to generators quite frequently. That's the picture on the left. And then maybe there's a motor control center that has different equipment plugged up to it at different times. So this can make your connect and disconnect a lot quicker and easier. HVAC disconnect. So my picture shows a more commercial residential type unit, but I've got a lot of plants that like the idea of their electricians not having to be involved in zero energy for HVAC operations. So sometimes these plants have extensive HVAC operations. So they have to spend a lot of time verifying zero energy for HVAC guys. And with MELTRIC, they can completely eliminate that cost. So I have people installing them for that purpose. And sometimes people don't even have electricians. I went to a BASF plant up in South Carolina. I think it was Charlotte, and they had all these HVAC operations. So they said in one go it was going to pay for an electrician. We've got the U.S. Postal Service looking at it for cleaning out mail sorting systems. And we have ways of changing MELTRIC so that it won't give you as many health and safety benefits, but it will prevent people from ripping out your electrical every time they drive away. We're used in baggage handling systems, particularly for explosion detection systems and the conveyors that feed in there. And you can retrofit very easily. We can get you retrofit plates.
Okay. Sounds good.
All right. Well, thank you, everybody, and we'll be in touch.
Bye then.
Thank you.